Cisco certifications were adjusted in February of 2019. Prior to that, in order to become a CCNP, you needed to become a CCNA, which you could do in one of two ways. Either take two tests, the ICND1 and ICND2, or just take what's known as the CCNA test, which was basically both of the other tests combined into one. Your choice how you wanted to do it. I actually did the ICND1 and ICND2. And then you needed to pass three professional level tests: the CCNP route, CCNP switch, and the CCNP T-shoot tests. For the Cisco CCNP switch test, there's a lot of command memorization. So what I did in order to prepare for it, I created a lab that covered all the test objectives associated with command memorization. And I put it all into one lab. And then prior to taking the test for several weeks out, every day I would run through the lab in order to build the muscle memory, or multiple times per week at least. And that would give me the preparation. So when I sat down for the proctoring and Cisco threw me some kind of sucker punch question about syntax or whatever, I had sufficient preparation in order to counter it, and did pretty well on the test. I was pretty happy. Passed it on the first time. All right, so let's go ahead and get started here. With the equipment that I am currently connected to, it's a eLab, but it is actual hardware that has a console cable connected to it. And console output can be a little bit squirrely because when there's messages that pop up in the console, the cursor moves over. And sometimes as you're entering big commands, that can become annoying. So to get around that, go into line con 0 and you issue the command logging synchronous. What that does is it redraws the line just like that anytime a console message shows up, so your prompt left clean. All right, next portion we're going to cover is LLDP and CDP, which are two discovery protocols. LLDP is configured with the command LLDP run. Boom. And then CDP is on by default, but I upped the version V2. It's better. It's got more CLVs associated with it. All right. This switch actually has one port connected to a telephone for other labs, and it's common to disable CDP on any access-facing interface or edge interface. So no CDP enable, disable CDP on the interface. Similar with LLDP. We're going to kill both transmit and receive. We're going to leave CDP enabled. No CDP enabled. All right. Next thing is VTP, VLAN Trunking Protocol. Kind of a cool technology. In the new enterprise track, they basically dropped VDP from it. It's got a lot of bad press, but when you study it, it actually is a pretty cool technology under the hood, as long as it's used correctly. Commonly wasn't, and you can cause a lot of havoc if you don't do it correctly. First thing we're doing is throwing it in transparent mode. And I'm going to do a do show. Current revision is 0. You always want to check your revision before proceeding with fully configuring your VTP so you don't zero out your VLAN databases. Making the mode client because NY Core 1 is a server. Setting it to VTP version 3 so we get the cool features associated with the newer version. So I'm setting a VTP password, and the hidden portion of that command makes it encrypted in the config. And if you look above, there's a console message indicating that it picked up VLAN. Let's do a do show VLAN. Oh, I know why. Connectivity to the other switch is not configured yet. We're going to take care of that here in a second. All right, let's configure some VLANs. Just got to zero out an address that's left as a config artifact from another lab. Yeah, so, all right. Go in here. And again, this switch has the access layer interface. We're going to take care of that one. Okay, so the reason why I do this is because first you need to zero out the voice VLAN just in case there's one out there. Otherwise, it causes some swirly configuration. And then you add it back. Creates a clean config. Kills DTP. Dynamic trunking. Done here. All right, let's configure some LACP or Ether channel. So interface range command is actually called out on the test objectives, and this is the correct syntax of it. You would think it would be interface range FA1023 through FA1024, but that's the actual syntax. It's a little bit tricky. Common trip up question on tests. set the LACP control protocol. And just very briefly, you don't need LACP in order to create an aggregate or a lag. LACP is a control protocol that can be used to negotiate lags, but you don't need it. In this case, we're using it. We're going to set this one to passive. The NY core one is active. All right, all looks good. Flags are SA. No, SP on this device, SA on the other device. I'm waiting for BTP to populate my VLAN. So far, it hasn't done. Let's do a trunk. 802.1q. In fact, I forgot to mention 802.3 AD is the standard that covers ether channel or lags, and LACP is associated with 802.3 AD, but it's just part of it. You don't need it for creating a lag. 802.1q is a trunking standard. Configuring two interfaces at the same time. Saves a little bit of keyboard hammering. Which port? Trunk encapsulation. .1q. Switch port. Mode. Trunk. So we. Oh, because I put it in transparent mode. Change that. There's all my VLANs. They finally showed up. I basically didn't do anything. It just took a while. Once the ether channel came up. All right. Good. Still in the interface range section of the configuration. Okay, so on the other switches, which is acting as the VTP server and the VTP primary, I created a native VLAN 99 called Black Hole. This is a result of the I created a VLAN called 99 Black Hole, and then I put it as the native VLAN on the 802.1q trunk. The reason you do that is because the concept of native VLAN or untagged VLANs on an 802.1q trunk can cause a security problem with something called VLAN hopping. So it's good security practice to create a black hole VLAN and put your native VLAN in it, or just tag all your VLANs. There's two choices. Both get called out on the objectives, and I'm in this lab. I'm doing it this way with the black hole VLAN. The VLAN is actually set to a suspend state, but we're also on the 802.1q trunk going to remove the VLAN. So there's a VLAN there, and then we're removing it from the trunk as an allowed VLAN, and it's also in a suspend state. So it basically fixes that three ways. And then we kill dynamic trunking protocol. Again, a good security practice called out in the objectives. Let's do spanning tree. What did I do wrong? I think I forgot to assign the VLANs. Stick with me. Yeah, it's ether channel. That one always trips me up on the test also. It's not show LACP, it's show ether channel. Yeah, it's got the interface. Why can't I ping across? That's probably because. Oh, there it goes. There it goes. Took a second. All right, on with the parade. Spanning tree. Put it into rapid per VLAN spanning tree plus mode because that's cool. No one likes the old stuff. All right, so this command kicks a macro that will calculate what priority value to put into the VLANs. The other switch, NY Core 1, same command except primary. Boom. Done. So there's a feature in Cisco switching called root guard. And just because they like tricky test questions, I don't know what other reason they could have come up before this, but the actual command is guard root. It should have been spanning tree root guard to enable root guard, but it's not. It's guard root. Go figure. Next thing we're going to configure is HSRP. Okay, so the reason why I created a key string for HSRP is it's one of the test objectives. Very rarely would you actually create a key string for HSRP switches. It's just a man in the middle attack for HSRP is an extremely rare event, but it is a test objective. I suppose in high security environments it might be a requirement. Here I'm setting the HSRP version to version 2, newer version with all the cool features. And by group 1, priority 95. I'm decrementing the priority from the default. I'm enabling preempt, but the other switch has a higher priority, so it will be the HSRP, not master. That's for so it is. I forgot the name of it, but it's the primary one. This one is going to be the secondary one. Here's where I applied the password. All right. Show standby. Yep. There it goes. Looks good. All right, logging. There are multiple test objectives associated with time stamping and logging. This covers those. Set the time zone to Eastern Standard, which is -5 from GMT. Because we in the States like to adjust our time twice a year, you need to do the summertime command. Summertime when the weather is fine. Summertime when the weather. Enough karaoke. And I need to set my clock. Again, this clock set command is part of the test objectives. So getting it right in the syntax is important in case they sucker punch you with one of these questions. The syntax is clock set hour 19 14 seconds. Date is 16 June 2021. All right, so what this command says is that you're going to stamp log messages with the timestamp, and you're going to show the local time for the time zone, and you're also going to add the microseconds. What this command does is on the axis facing interface, it disables creating a log message for every up down status. So the concept is that if you're in an enterprise, you have a bunch of axis facing interfaces, you don't want to create a log message every time someone unplugs their laptop and goes home for the day and then plugs it back in the next morning. It's redundant. So this takes the log messaging off. All right, we're now going to configure some basic security. Kill the HTTP server, which Cisco has enabled by default on almost all their devices. Not sure why. In the HTTPS server. Now let's do some AAA. This created a user of last resort. So if TACX fails, we still can get into the router via using a local user. All right. So you might be asking, why are you putting in a complicated password? This is just a reminder that you want to keep these things secret. I'll put it in a bogus password for places where it doesn't really matter, like the HSRP one. For this one, it actually does matter. Keep your TACX server keys secret, similarly to the username of last resort. And for redundancy, we add a second TACX server. We wouldn't put it in the same subnet in real life, but this is just a lab. So that defines the TACX servers. We're not actually using them yet. And I'm going to create a group of servers. Now I could actually add the servers predefined previously. All right, so the local case at the end there makes the passwords and usernames case sensitive. Which BTY lines are 0 through 15. And that adds the authentication method to the BTY lines. Let's add some accounting. So if you're not currently using AAA accounting in your environment, you should. Offloading commands that are entered into your device to a centralized accounting server or syslog server is an important security practice, and that's what I'm doing here. I'm saying it to the TechX servers, which will do AAA accounting for. This is where I'm doing the commands that get entered in privilege level 15. Start stop. You can look up what that means. It's kind of complicated. I'm not going to explain it. Group. There's basically different ways of recording the commands. Start stop is a good one. All right. There's also something called out on the objectives called VACLs or VLAN ACLs. Let's just do that real quick. First, we created a simple access list. So in Cisco tests, one thing that you'll need to keep track of is when an access class, an access map, and an access list is used in the config. Those are very common triple questions. In this case, we're doing an access map. Creating an access map called VLAN 20, and the 10 indicates the line number or the statement number. Fetching all IP addresses in the standard access list. We're going to forward those. Twenty is the statement number. We're going to drop everything else, and we're going to apply it to a VLAN. That's it. Quick show span. Shows that the root ID ends in D00. What is this one? I'm sorry, 9D00. This is 5D00, so I'm not the root bridge. It shows where I'm. Let's not do all that. We already did the show ether channel. I think that's it. All right, so there's also an access layer switch which has additional security associated with it. These are the core switches that do Ether channel and 802.1q trunking, or the Ether channel is 802.3 AD, and then the 802.1q trunking on top of the 802.3 AD. The access layer switch, I'm going to go through on a separate lab. I think we've gone long enough.